Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at graphs of trigonometric functions. So by the end of this lesson you'll be able to do these four things: explain what a periodic function is, sketch the unit circle from memory, sketch trig functions in degrees, and determine the periodicity of simple trig functions. Okay, let's have a look at the first part of the lesson, periodic functions, and what they are. So here we've got a Ferris wheel. Let's say, for example, we want to determine, let's say you get onto the Ferris wheel right here. So let me just draw a realistic person. And as time goes by, you go around the Ferris wheel. Round and round and round you go. And let's say we want to work out the height that you are at as time goes by. And let's just assume that it takes 4 minutes for you to do one complete revolution, one complete cycle, 360 degrees. So if it takes 4 minutes, so let's call this T for time, time in minutes, and we'll just call this H for height. You get on at time equals 0, and let's just say that you're at about this height. 1 minute later, let's see how high you are. I'll just keep going. 5, 6, 7, 8, 9. That's good enough. Okay. So 1 minute later, you've gone 1/4 of the way because it takes 4 minutes to go one complete revolution. 1 minute later, you're up here, which means you're at this height. But I'm going to put a dot there because that's where you are 1 minute later. 2 minutes have passed. Now you're at the very top. Okay, you're up here now. If we were to draw how high you are after 2 minutes have elapsed, you're up here. What about when 3 minutes have elapsed? When 3 minutes have elapsed, you're over here now. Which means technically you're at the same height as you were when 1 minute had passed. So you're going to be over here. And then at 4 minutes, you're going to be right back where you started, down here. What about after 5 minutes since getting on? You're going to be back up here. 6 minutes, you're going to be back at the top. 7 minutes, you're going to be back down here. 8 minutes, you're going to be back where you started. 9 minutes, back up here. We can see here that if we were to actually graph it properly with a smooth curve, it's going to form this sort of graph. Okay. And this is what we call a periodic function, right? The graph of the height of the Ferris wheel as time goes by is an example of a periodic function because the shape continues to repeat every 4 minutes or every 360 degrees technically, right? Because you're going one full rotation or revolution. So technically 360 degrees, you're going back to where you started. Now the trig graphs y equals sine x, y equals cosine x, and y equals tangent x are also periodic functions because each graph repeats itself over and over again. Now, in order for us to graph these functions, I think it's best for us to go through how to actually sketch the unit circle. So I'm going to quickly teach you how to sketch a unit circle from memory. So here we've got a unit circle, and it's important for you to know these angles. That's 30, 45, and 60. Let me put a 0 in as well. 90 degrees. And they're the main ones you need, right? Once you know how to do that, you should be able to complete the rest. I'm just going to put the rest of these angles in. So this is 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330. Okay, and they're all in degrees. Okay, so we know because this is a unit circle that the first thing we're going to do is we'll just put in these coordinates, that this is 1, 0, this one is 0, 1, this is -1, 0, and here we've got 0, -1. What you need to do in order to memorize this is just memorize these three. Once you've memorized those three, you can just reflect them for the other three quadrants, and it'll be nice and easy. You just need to know which ones are negative or positive. So in order to do this, what we need to do is we need to label the coordinates, and they're always going to be over 2 for all of them. Then we're just going to go down 1, 2, 3, and then go back up 1, 2, 3, and then we'll just square root the numerators for all of them. But the square root of 1 is just 1, so we don't really need to do that. I need to put square root on all of these ones. And that's it. And just so that you remember, the first coordinate, the x coordinate, that's cos, and the second one is sine. Okay, so first coordinate, x is cosine, y coordinate is sine. Now that we've done that, we can actually just reflect this across the y-axis for the second quadrant. So I'm going to write exactly the same thing for each of these. So we'll have 1 over 2, root 3 over 2, root 2 over 2, root 2 over 2, and this one here will be root 3 over 2 half. I realized I didn't need to write that. Square root button. Okay. The thing is, on the left part of the y-axis, x is 0. Sorry, x is negative. So we're going to put negative signs in front of them. And then we can do exactly the same thing. We can just reflect that across the x-axis. So that means this one here will be root 3 over 2 half. Then we have root 2 over 2, root 2 over 2, and then we've got half and root 3 over 2. Except in this quadrant, both x and y are negative. So I need to write negatives for all of them. And then for the fourth quadrant, I can reflect this one, or I can reflect that one. It doesn't really matter. I like to reflect the first quadrant up here. So we'll have root 3 over 2 comma half, root 2 over 2, root 2 over 2, and then we'll have half root 3 over 2. Except here, this is below the y-axis, so only y is negative. Okay, so that's important because when we actually sketch our trig functions, that's going to help. So here I've got an example of how to sketch trig functions in degrees. I've got the unit circles for all of these, and we're going to sketch y equals sine x, cosine x, and tangent x. So when x is 0, when the angle is 0 degrees, what is sine? Well, we know that sine, because we're going to do the sine curve first. We know that sine is the y coordinate for each of these. So what we could do is we could just highlight all of the sines, all the y coordinates, and then we can graph this. So sine of 0 will be 0. Sine of 30 degrees, that's here, is half. Let's just say that this is half. And that's 1, negative half, and negative 1. Sine of 30 is half. Sine of 45 is root 2 on 2. Now, what is root 2 on 2? Let's just put it in our calculator. Root 2 on 2 is approximately equal to 0.71. 0.71, that's 0.75, so it's probably about here. 60 degrees is root 3 on 2. So let's see what that is. Root 3 on 2 is about 0.87. Probably about here. And then 90 degrees is 1. So sine of 90 is 1. Let's keep going. 120 degrees is root 3 on 2. Well, we already know that that's up here, about 0.87. Sine of 135 degrees is root 2 on 2, which we already know is about 0.71 down here. I'm sorry. It needs to be over here. Sine of 150 degrees is half. Sine of 180 is 0. Sine of 210 is negative half. Then we've got negative root 2 on 2, which we know is going to be negative 0.71. So I would say it's probably around here. Negative root 3 on 2, about 0.87. Let's just say it's about there. And then negative 1. And it's going to go back. And then 360 degrees is back at 0. So now that we've done that, we can actually join the dots. It should give us a nice curve. Okay, and this is called the sine curve. Y equals sine x, where x is the angle. And it's actually going to keep repeating. So for example, if I were to continue graphing this, let's just say that that extends out here beyond 360 degrees, it's going to look exactly the same like the Ferris wheel example. It's just going to keep repeating. Okay, it's just going to keep repeating. It looks exactly the same. This time, we're going to have a look at how to sketch the cosine curve. Now, for the cosine curve, remember, it's always the x-coordinate that represents cosine. So we can just highlight all of these, and then we can graph them. So I might start off with the first, maybe 90 degrees, and then I'll get you to see if you can work out the rest. But before I do that, let me just label the y-axis. So we have 1, 0.5, 0, negative 0.5, and negative 1. So the cosine of 0 is 1. Cosine of 30 degrees is root 3 on 2, which is 0.87-ish, right up here. Cosine of 45 degrees is root 2 on 2, which is about 0.71. Cosine of 60 is half, and cosine of 90 is 0. I forgot to highlight that. Okay, then that I've done that, I'll get you to pause the video and have a go with completing the rest of this cosine curve. Okay, so here's the cosine curve, and just so that you know, it actually keeps repeating. Like I said, it's a periodic function, so it's just going to keep repeating itself. Just imagine that you started at the top of the Ferris wheel, and then you're just going down and then back up. Okay, so if we were to continue this, it's going to look something like this. Okay, it's just going to keep repeating and repeating. All right. What about the tangent curve? So here, what we need to do is to remember that tangent is actually equal to sine over cos. Right, so maybe we'll write that over here, that tan is the same as sine over cos. Well, if the x is cosine and the y value is sine, technically we've got root 3 over 2 over 1 over 2. You will then notice that the 2's will just cancel each other out, so my fraction is just root 3 over 1, or just root 3. Now, the shortcut for this is just to take the numerators only, and just do the numerator of sine over the numerator of cosine, and that's it. It's just root 3 over 1. So for example, if we wanted to work out tan of 45, which is equal to root 2 over root 2, which is just 1. Or if we want to do tan of 30, will be 1 over root 3. Okay, so that's the shortcut method. So let's see what it looks like. Now, the tan curve is a little bit different, so I'm just going to label this, let's go with negative 1 over here, 0, negative 1, sorry, not negative 1, positive 1, and we can have 2 here and negative 2 here. Okay, so if we wanted to work out tan of 0 degrees, tan of 0 is just going to be 0 over 1, which is 0. Tan of 30 degrees is going to be 1 over root 3. 1 over root 3 is about 0.58. So let's just say that's about there. What about tan of 45? We know that's 1. I already went through that one. Sorry, tan of 45 is over here. Tan of 60 degrees will be root 3 over 1, which is just root 3. 1.7. And then tan of 90 will be 1 over 0. But we can't divide by 0, right? We get an error. So that means it's not possible to have this. So there's going to be an asymptote here. Alright, what about tan of 120? It's going to be root 3 over negative 1, right? There's a negative there. So we have root 3 over negative 1. That gives us negative 1.7. About here. Root 2 over negative root 2 is negative 1. What about when x is 150? 1 over negative root 3. 1 over negative root 3. Negative 0.577. What about when it's 180? Whoops. It's going to be 0 over minus 1, which is just 0. Alright, how about I get you to pause the video and then see if you can finish this tangent curve by yourself. Okay, so I've placed my dots. So now I can graph this. I know it's going to go up like that because there's an asymptote here, so we'll never actually reach it. Never actually cross that line. Put another curve like this. And another one like this. Okay, so this is y is equal to tangent of x. Okay, now again, this will continue to look exactly the same if we just kept going. So if I were to draw another line from here, just brought that down here, good enough. It's going to keep going, and then there's going to be another asymptote, and it's going to keep going, and another asymptote. Okay, it's just going to keep repeating itself over and over again. So now we know how to graph the sine, cosine, and tangent curves. let's have a look at periodicity. So this is something nice and simple. The period of periodic functions such as y equals sin x, cosine x, and tangent x refers to the length of the smallest repeating unit. The sine and cosine curves both repeat every 360 degrees. Therefore, they both have a period of 360 degrees. However, the tangent curve repeats every 180 degrees. Therefore, it has a period of 180 degrees. So if we have a look here, sine curve, (360 degrees), and then it repeats itself. So every 360 degrees it repeats itself. Cosine curve starts up here, comes down, goes all the way back up, and at 360 degrees it starts again. Okay, so every 360 degrees it repeats itself. However, with the tangent curve, we can see that it repeats itself every 180 degrees. So maybe it's easiest if we start here between 90 and 270, and then after 270 it starts again, and then it starts again every 180 degrees. Okay, and so that's it for this video. Thanks.